Dear students, good morning. In the previous classes, we discussed about the subject like fiber optics and laser instrumentation, isn't it? So almost two chapters are covered, and we have the remaining simple concepts are there in the chapter two, like gyroscope and some biomedical application, right? We'll see that in the coming class, right? And we have other subject. So I want to deal the two subjects, right? One is fiber optics and laser instrumentation, and one more analytical instrumentation, right? So for this analytical instrumentation, already I have taken one subject as in introduction, right? But you maybe forgot that concepts. Again, I want to review on this the same concepts, analytical instrumentation, right? And in this analytical instrumentation we have four chapters, right? The first chapter describes the basic concepts. What is the meaning of analytical instrumentation, what is the basic block diagram, and what are the instruments available, and what are the principles that are implemented for each instruments, isn't it? These are the simple concepts are available in the chapter 1. Like this, chapter 2, chapter 3, chapter 4, we want to use the different methods for analyzing uh, the samples, right? These about the four chapters. It includes analytical instrumentation, right? So you know that what is generally, what do you mean by analytical instrumentation, or what is analysis? So you have the subject in the, I may, you have the subject electrical technologies, for example, electrical technology. So for this circuit, for any circuit, if we give any unknown current, if we give any current, you want to get some voltage at the across any diode, or across any capacitor, or any across any resistor, isn't it? So there is a complex circuit is there. It's not a simple circuit. You remember, it is not a simple circuit. It may be complex circuit. So you, what can you do? How do you get the voltage across any electrical component? Maybe resistor, capacitor, or something inductor. So what can you do? You apply some techniques like mesh analysis or node analysis. What are these two? So these are the methods applied on the available circuit such that we want to get the output. You want to get the known no voltage by the application of the input, maybe current, maybe another voltage. Leave it. But so the way to get the voltage at the end is with the help of analysis, Kirchhoff laws, Norton's theorems, maybe reciprocal theorems, isn't it? So different methods are available for analyzing the circuits by writing some loops, current loops, isn't it? So this is the way we want to get the output at the end of the circuit by this way of analysis. So analysis is very much important in all the sites, not only in these analytical instrumentation sites. So not only in the maybe in the any chemical process sites. So anywhere this word is suitable for knowing the unknown things analysis. Some measurements may be directly, some measurements may not be direct. So indirectly you have to get the unknown one. So indirect the way nothing but analysis. We have to get some analysis on this, isn't it? So that is enough for this. And in this chapter, the analytical instrumentation, so we want to see what is there actually inside the subject. First of all, you have to know what is the actual definition of analytical instrumentation. In this analytical instrumentation, is a subject, is a study of separation. Remember, is a separation and identification and quantification of the chemical components. Chemical components. So is it So, is it visible to you? Once again, leave it. Wait 1 minute, ma. I will show you. Yeah. See that analytical instrumentation is the study of separation, identification, and quantification of the chemical components of natural, sometimes artificial materials. So, this subject completely describes the 3 to 4 parameters. The parameters are nothing but you take any chemical components, any samples, maybe liquid or any powder or any mixture components, isn't it? You take any mixtures, different compositions. So what can you do on these chemical components or on the mixers or on the powders? You do something. What you are going to something? You apply the technique. You apply the method of analysis. So we have different methods. The complete 4 chapters of analytical instrumentation completely describes different methods, different techniques applied on the chemical components so that we can separate the chemical components and we can also identify it and we can also how much component, how much quantity is available in the sample, so that the 3 things can be analyzed with these available techniques. So this with the help of available techniques and we are focusing on the sample, we want to separate it, identify it and quantify it. So this is the process so called analysis of a chemical component. This analysis process so called analytical instrumentation. So why it name as instrumentation? Instrumentation nothing but with available instruments we want to do it. So we have a number of instruments available. So with these available instruments, we want to separate the sample, identify the sample, measuring the unknown pH values like this. So this can be done with the help of instrumentation. So it name as analytical instrumentation, right? So you have the subject like process control instrumentation and industrial instrumentation. So what you are understood there in the subjects? So in that subject, if it is industrial instrumentation, with the available instruments, you are measuring the unknown velocities or unknown accelerations, isn't it? With the available instruments, you are going to measure unknown pressures, forces, isn't it? Flow, liquid levels. So how it can be done? How you are easily measuring all these industrial parameters which are available in the industries? With the help of instruments. So it name as industrial instrumentation. So in the industries with the available instruments, you are measuring the unknown parameters like this. Right. It's coming to the case of process industry. In the process industry also with the instruments, you are measuring the unknown chemical related parameters. I mean process variables. Process variables. It may be again flow and velocity, viscosity, density, all these comes under this process, right? So there also you are using instruments. If it is industrial instrumentation, you are using instruments. If it is process control instrumentation, again you are using instruments. Suppose if it is analytical instrumentation, again you are using instruments. So without instruments, no measurement. That's what my point. Without instrument, no measurement. So in this analytical instrumentation also, you are using instruments for analyzing, that means separation, identification, and quantification of the chemical components or chemical compounds or any chemical mixtures. It may be natural or it may be artificial. So that is the main idea is in this media. Main idea is present in this analytical instrumentation. Fine. Then what is the block diagram? What are the elements available in this analytical instrumentation? Generally, you are familiar with this concept of transducer, isn't it? So everywhere, if it is instrumentation, the word comes as instrumentation. Definitely you have to imagine that there is a transducer and there is a signal conditioner, no doubt it. In any instrumentation, without the two blocks, there is no instrumentation meaning. So in these elements of analytical instrumentation, generally we have the four blocks available. Of course, if you want, as per your requirement, as per our process, analysis process, available chemical components, we can you can place number of blocks, no problem. But actually, generally, there are four blocks available in this analytical instrumentation, right? What the first block? The first block is nothing but chemical information source. Is a source like input signal, right? Chemical information source. And second block is transducer. Third block is signal conditioner. Lastly, it is a display or readout. So, how the process is going on, how this analysis is going on. In this analysis, first of all, with the availability of chemical component or any mixture or any chemical compounds is nothing but chemical information source. So, with this block, we have a sample, chemical sample. Any unknown, suppose if you want to know, find out the pH value. So what the input to this? You can take any water or you can take any petrol, isn't it? Or you can take any oil like this. So we can, that is called a sample, chemical information source, right? Or any acid material you can take, acidic material, right? So that is nothing but a chemical information source that is acting as input to the transducer. So when the transducer accepts the chemical input or any chemical source, what is the main function of this transducer? You are familiar with this word transducer. What is a transducer? Transducer is a device. It converts one form to suitable form. Suitable form. Generally, a transducer, if it is electrical transducer, it converts non-electrical signals into electrical signals. Electrical signals. So that is a form of electrical transducer. You know that transducer, different types of transducers available: passive, active classifications, resistive, inductive, capacitive transducers, and different categories. And you know different applications of the transducers in the II1 and II2, right? So we know that complete information regarding this transducer. Fine. And the output of transducer is given to signal conditioner. What is signal conditioner? Signal conditioner is nothing but it is electronic circuit. Is electronic circuit. So the output of transducer is sometimes generally is very less output. Less output means in terms of millivolts. In terms of millivolts. So millivolts cannot be processed, cannot be, cannot be transferred or transmitted to long haul distance, long haul purpose. That means in any plant. So there is a control section and there is an instrument. There is a control section and your plant is so far, isn't it, far from your control section. So what can you do? You cannot transmit that signal, very less signal. So what can you do? You have to amplify it. That output of transducer should be amplified, sometimes attenuated. If any noise signal is presented, you have to attenuate it, then transmit through some telemetry. through some telemetry technique we have to transmit it. So, so there should be some process is done on the output of transistor. So who can done this process, amplify and attenuate all these? So we need electron circuit, nothing but signal conditioner. After the signal conditioner, you have to get that display. The display nothing but readout. The display may be analog, maybe digital sometimes. So how can you do this analog and digital? Analog means to take any voltmeter by showing any pointer deflections, or take ammeter by showing any pointer deflections, or with the help of digital instruments, digital display in terms of numerical values. So you can display analog, the output of signal conditioner, or you can display in terms of numerical values, 7 segment display, otherwise 7 segment display. So this can be done in general, so that the unknown component can be analyzed in this analytical instrumentation. Clear? So these are available 4 blocks. We can analyze the chemical component. Next one is, what is the block diagram? So this block diagram can be represented like this. So the red arrow mark represent the input. Arrow mark is nothing but input. That is called stimulus. Stimulus. So what is the stimulus? We have to stimulate the sample sometimes as per the requirements. So you cannot use all the stimulus for each process. I cannot say like this. So whenever it is required, whenever whenever the samples is varying, the samples are varying, the stimulus also varying. So based upon the sample, you have to select the stimulus. That may be light sometimes, light, that may be heat, that may be current, that may be voltage. So you take, these are the stimulus which will fall on the sample. This is a sample container. So with this sample container, that is given to the input transducer. So it can act as a transducer, sometimes again as detector, as detector. Okay, that output of transducer is given to the signal conditioner or any processor. So as you know that the meaning of signal processor nothing but it may be amplifier, it may be digital, it may be attenuator, like this. Sometimes it is equalizer, it may be noise detector, right? So any form of the signal processor, it will process some data on the available signal. That is the yellow mark represented by signal processor, and this green represented transistor, it can act as a detector element. Then the output of the processor is going to give a readout. So readout, it is a display. It may be meter or any plotter, or maybe sometimes computer. So what is meter? Meter nothing but like ammeter, like voltmeter, or any digital instrument um, like multimeter. You can take multimeter, isn't it? So that based upon the signal you want to measure, you can place the position in the multimeter, right? And sometimes the output is measured in terms of plotter. Plotter nothing but a graphical readout. Is a graphical approach. Sometimes the signal cannot be measured with the available meters. So what can you do? Do it with by representing as a graphical plotter. So there are number of graphical approaches, methods are available. XY recorder, isn't it? The XY recorder is a good example for the plotter. So we can plot the two variables X and Y axes on the same graph sheet. So that is nothing but a plotter. Or any, you can take ECG, so electrocardiogram. So what is that electrocardiogram? Is a graph represent the heart diseases problems that can be identified by knowing, by carefully examining that ECG report, isn't it? ECG report So ECG report nothing but a plotter, is a plot, is a graph. Sometimes the output can be read out with the help of computer. Sometimes, there is a need to need to represent the output in terms of a digital value with these available computers. Digital computers you can take. Sometimes you can take any CRO, cathedral oscilloscopes, CROs, isn't it? Sometimes, digital CROs, digital CROs, sometimes spectrum analyzers. So what are these? These are all comes under plotters. Sometimes computer-based results. So, in this, if you want to analyze any sample, any chemical sample, any powder, mixtures, compounds, it can be done with the help of all these processing elements. Without these processing elements, without this instrumentation, there is no analysis. There is no analysis. So this block diagram represent the exact meaning of analytical instrumentation. Next, next, this is nothing but electromagnetic spectrum. Electromagnetic spectrum. So you know that you want to apply some frequencies. You have to apply some frequencies, or any light. You are simulating some light on the sample, isn't it? In the previous diagram, stimulus comes stimulus, light acting as a stimulus, or any photocurrent, isn't it? Or any frequency. So the photocurrent or any light, we are falling on the sample. So when the light fall on the sample, the characteristics are modified. Characteristics are modified. So that light having some frequency, some intensity, some parameters, right? So the light nothing but what? Electromagnetic wave, is electromagnetic wave. We are representing that light in terms of crest and tuff. Crest and tuff is a sinusoidal manner, isn't it? So when the, if you take any two signals, if you take two signals, when the crest are matched, you can take dark, isn't it? With crest and tough mass, you can get. So I'm sorry. When two crests are combined, you make it bright. If the crest and tough are matched, we may get dark. That's called fringes. That's called comes under fringes, right? And in this electromagnetic spectrum, which is represented as a sinusoidal manner, and this complete spectrum we can divide into number of frequency ranges. Number of frequency ranges as per the wavelength of the light. Wavelength of the light. See, these graph represent completely the wavelength. Completely the wavelength. Wavelength versus frequency. So this range comes under gamma rays. This is comes under X-rays, and this portion comes under ultraviolet spectrum and visible spectrum. Remember, okay, examine this graph. Which is I am showing on the screen. So this completely spectrum occupies different frequency ranges. So which frequency range you want for applying on the sample, that is based on the requirement of the process. Sometimes we require gamma rays frequencies, X-ray frequencies, and these ultraviolet spectrum frequencies, and in this visible spectrum frequencies. In this ultraviolet spectrum, we can have UVC, UVB, UVA. Again, we have three categories. And infrared frequencies, microwave frequencies, radio frequencies. So, you can select the frequency range for one application of the sample, right? That is your wish. And one more, we have different instruments subsystems, different instrument subsystems, so that we can analyze any sample in this analytical instrumentation. See, these are the instruments available. Roughly, these are instruments available, and this is the characteristics of model. It may be analytical signal and input transducer and outputs, and this is processing model. Processing model. Say, for example, photometer. Photometer is an instrument. It will analyze attenuation of the light beam. In the photometer, it will analyze light signal. So the input transfer is photocell. We are using photocell whose output is electrical current. Electrical current. So how do you measure this electrical current as output? With the available ammeter or current meter. Current meter. So for the instrument, we are analyzing on the signal, light signal we are analyzing. So we are using photocell as a transducer, photocell as transducer whose output is electrical current that is measured with the help of ammeter or current meter. And you can take pH meter. Say for example, pH meter. In this pH meter, hydrogen ion as the analytical signal. The basic element is hydrogen ion. Hydrogen ion. So what is input to this? The input is glass column electrodes. Glass column electrodes. Output is electrical potential. So how do you measure this electrical potential? This can be measured with the help of digital display. Digital display, or maybe voltmeter. Voltmeter. How do you measure this digital voltmeter voltage? So the output of electrodes, nothing but signal that is amplified and converted. Amplified and converted. That is nothing but signal processor. Signal processor. So the output of electrodes is amplified and converted so that you can get digital output that is measured with digital display. So like this, we have atomic emission spectrometer. So the analytic signal is UV or visible radiation. Just now we observed the frequency range. And the input is photomultiplier tube. Output is electrical potential. So this output is amplified and demodulated so that we can record as a graphical approach. Chart recorder nothing but is a graphical approach for knowing the sample analysis. Like like this color comparator, XY X-ray powder, diffractometer. So diffraction X-ray record radiation, photographic film we are using. Output is image. That image is processed in the chemical developer. So if you take any snap with the mobile or any photo, I mean, uh, you can shoot with the mobile. Then we have some image. How can you develop this image? We need some chemical developers, isn't it? Chemical develop. So we can, after a development, we can get the image. Based upon that image, we can uh, retry the unknown present. Like this, we have different instruments available. So and different concepts, different methods also available. You can select different method, different instruments for analysis of this signal. So generally, these are the factors available, steps available in this analytical instrumentation. Some steps available, steps of AI. So first one, define the problem, select the appropriate method, obtain, obtain and store the sample, right? And pre-treat the sample, perform required measurements, compare results with standards, then apply necessary statistical methods. Next, present results, inform, understandable to analyze, right? And lastly, present results to customer. These are final output. Final output. So they are the steps available in analytical instrumentation. Lastly, so where this where this analytical instrumentation is going to be applied, is going to be applied. So applications of AI, sir. last slides. So this is application of AI. So this analytical instrumentation can be applied in pharmacy side, pharmacy, and biotechnology sites, microbiology sites, environmental applications, environmental applications, and laboratory applications. So how it is used in the pharmacy sites? In the pharmacy, drug discovery, drug chemicals, drug means medicines, quality assurance, regulatory compliances, clinical studies. So these three comes under pharmacy sites, pharmacy industry. Next, biotechnology sites, proteomics and genomics for knowing all these concepts under biotechnology sites. You can use this analytical process. Microbiology sites, rapid microbiology, food safety. Under this, you can use this analytical instrumentation. Microbiology sites. Environmental applications like pollution control. Yes, pollution control and pesticide residue analysis. Pesticides, the farmers are using some pesticides. You want to analyze that whether how much suitable uh, urea is available and other chemical parameters available, whether they are in right manner or not. We want to know it before going to sell to the customers, right? Environmental applications, pollution controls, and lastly, laboratory automations, laboratory sites in the research works, sample preparations, right? So, in all these areas, this analytical instrumentation is very much useful, right? And remember, this subject is very much useful for your instrumentation uh, because if you have suppose if you are